Picture a book, a fat one, an old encyclopedia, gold letters down the spine. Every fact anybody ever bothered to write down pressed flat into its pages. Now carry it out to the strangest edge in the universe and let go. There is a place out there where gravity pulls so hard that nothing, not even light, can climb back out. A surface hanging in space with an inside and an outside, and no return trip. The book falls through, past the point of no coming back, and it is gone. The old story ends right there, gone, forever, swallowed behind a one-way door. But that is not where the story ends anymore, because that door, it turns out, is faintly warm. It glows, and if you wait, a preposterous amount of time, but if you wait, the whole black hole quietly shines itself away to nothing, until there is only a thin bath of featureless heat left behind. Warmth with no words in it, no gold letters, no pages, no facts. So here is my question, and I promise you I do not know the answer. Where did the book go?
That is the question, and genuinely one of the sharpest unsolved puzzles in all of physics. It took the field about 40 years just to agree it was a real question and not a trick of words. So, a promise for tonight. No mystery followed by a neat bow. We walk right up to the edge of what anybody knows, and I stay scrupulous about 3 colors. What we have proved, what we have good reason to believe, and what we are frankly only hoping.
Good, because where did the book go already sounds like a sentence somebody prints over a photo of a galaxy. So before you sell me anything mystical, I want to start from something I have actually done, something I could derive on the back of a page.
Then you will be delighted, because the front door to this whole subject, the size of that one-way surface, is a homework problem from your very first mechanics course. Wait, this is just escape velocity.
Hold on. A one-way surface, nothing escapes, not even light. That is just escape velocity, right? You take the escape speed off some object and crank its mass up, or its size down, until the escape speed reaches the speed of light. Past that, nothing slower than light can get away, which is everything. So light itself is trapped. That is a first-week problem.
That is exactly the sum. And it is not a modern idea. A country clergyman named John Mitchell wrote it down in 1783. A star so massive its escape velocity exceeds the speed of light, so the light, in his words, falls back. He called it a dark star. Pierre-Simon Laplace came to the same idea independently a few years later. So do the algebra you know. Set the escape speed equal to the speed of light, solve for the radius, and out falls a specific size. Twice the gravitational constant times the mass divided by the speed of light squared.
And that radius has a name, or you would not be smiling.
It is the Schwarzschild radius, the size of the horizon, the one-way surface. Named for Karl Schwarzschild, who in 1916, within months of Einstein publishing general relativity, and while serving on the First World War front, solved Einstein's equations for a lump of mass and found that exact radius drop out. So here is the delicious, dangerous fact. Your naive Newtonian sum and Schwarzschild's full solution of Einstein's curved spacetime equations give the identical size for the horizon.
Identical? A first-week sum, and the real relativistic monster agree exactly. That feels too lucky. Where is the catch? You have trained me to distrust anything that clean.
Good instinct, and the catch matters enormously. The number is right, the story underneath it is completely wrong. When Michel pictured light falling back, he imagined light as little cannonballs that fly up, slow under gravity, stall, and rain back down, like a ball you throw upward. That is not what happens. Light never slows down. Nothing about a black hole makes light heavy, or tired, or draggy.
So if it is not light losing a race against gravity, what actually traps it?
Geometry, the one genuinely relativistic idea I will ask you to hold, one step past your special relativity course. Mass bends space-time. Near a black hole, it bends so severely that at the horizon, every possible future path, every direction that counts as forward in time, points inward. Not most of them, all of them. Crossing it is not like flying too slowly to escape a planet. It is like the moment after right now. Once you are inside, the center is in your future the way tomorrow is. Light is trapped, not because it falls back down, but because there is no longer any out for it to point at. Every out has been tilted into an in.
That is a genuinely different picture, and I can feel that it is different. So, the escape velocity sum gets the size right, and I should never tell anyone light gets too heavy and falls back. The horizon is a one-way surface baked into the shape of space-time.
That is the exactly honest sentence. Keeping the right number while throwing away the wrong story is a very physicist thing to do. Now hold on to that surface, because it is about to do something no surface has any business doing. It is going to keep a ledger. The hot gas that broke the second law. Let me spoil your thermodynamics course for a second. You know the second law. Entropy, disorder, the number of microscopic ways a thing could be arranged, never decreases in a closed system. You cannot unscramble an egg. That is about as solid as a law gets.
Agreed. Entropy of the universe only goes up, drilled into us.
So let me break it. I take a canister of hot gas, high entropy, molecules careering around in a huge number of arrangements, and throw it through the horizon. It is gone, past the one-way door. Now look at the universe I am left in. The gas and all its disorder have vanished from it. The entropy outside the black hole just dropped. I appear to have deleted entropy, broken the second law with a canister and a good throwing arm.
That is genuinely uncomfortable because you keep saying a black hole is describable by almost nothing, just a mass and a size. I traded a bookkeeping nightmare of disorder for the simple thing, and the disorder is just gone? That cannot be allowed.
It cannot, and the person who refused to allow it was a graduate student. In 1972 and 73, Jacob Bekenstein, then working under John Wheeler at Princeton, proposed that the black hole itself must carry entropy. Throw the gas in, and the black hole's own entropy goes up by at least as much as you seem to lose, so the total never drops. He rescued the law by giving the black hole a hidden ledger of disorder.
But where would a black hole keep entropy? If it is basically a featureless pit, where does the bookkeeping live?
This is the part that should stop you cold. The seed of everything tonight. Bekenstein said the entropy is written on the horizon's area. Throw the gas in, the black hole gets more massive, the horizon grows, and its entropy grows with that surface area. His combined rule, the ordinary entropy outside plus the entropy on the horizon, taken together, never decreases.
The entropy lives on the surface, not filling the inside, on the skin. File that because it already sounds strange and you are grinning like it gets stranger.
It gets much stranger, and we will pull hard on that thread later. But first, a lovely piece of honesty from the history. That same year, 1973, three heavyweights, James Bardeen, Brandon Carter, and Stephen Hawking himself, wrote down 4 laws of black hole mechanics, and the mathematics matched thermodynamics term for term, with the horizon's surface gravity playing the role of temperature. And they did not believe it. They thought it was a gorgeous formal analogy because a temperature means a thing glows, and everyone knew the one thing a black hole does not do is glow. It is the definition of black.
So the experts, Hawking included, looked at their own equations, saying, this thing has a temperature, and said, surely not, that is just poetry. And I am guessing Hawking went home and proved himself wrong.
He went home and proved himself wrong. That is the heart of the episode, so let us take it slowly, out loud. Why the black hole is not black. To see why a black hole glows, we need one idea from your quantum course. You met the uncertainty principle, and at the harmonic oscillator, a strange fact. Even in its lowest state, a quantum system is never perfectly still. The vacuum, genuinely empty space, no particles, is like that. Not dead calm. The quantum fields filling all of space are always faintly jittering, never able to sit at exactly zero. Physicists have a vivid shorthand for it. Pairs of particles, a particle and its antiparticle, constantly flickering into being and vanishing again, everywhere, all the time.
The seething vacuum, little pairs popping in and out of nothing.
Right, and hold that picture loosely, because I am going to take it away in a minute. But run with it first, because Hawking did. Picture one of those flickering pairs born right on the horizon, straddling it. One partner just outside the one-way surface, one just inside. Normally they would find each other again and quietly annihilate. But this pair got split by the door. The inside partner falls in and can never return. The outside partner has no one to annihilate with, so it is stranded in the universe as a real particle, flying away. To keep the energy books balanced, the partner that fell in counts as negative energy going into the black hole, so its mass ticks down by a hair. Do that over and over, and the black hole is slowly radiating real particles and slowly losing mass. It glows, it has a temperature. Given enough time, it evaporates.
That is a beautiful little story, and I followed it completely, which is exactly when your voice in my head says, George is about to tell me the beautiful story is a lie.
Not a lie, a cartoon. And I have to label it hard because it is the single most repeated picture in all of popular physics, and it is a ladder we climb and then kick away. That pair splitting at the horizon image is a heuristic Hawking himself used to give people a feel for the result. It is not the derivation. The real calculation has no little balls in it at all. What it actually says is subtler and deeper. Near a horizon, observers disagree about what empty vacuum even means. Someone hovering far outside sees a steady thermal glow of real particles streaming out, where someone falling in sees nothing special. The radiation is a genuine feature of quantum fields living in warped space-time, the same family of physics as the Unruh effect, where merely accelerating hard enough makes empty space look warm to you. So, the glow is real, the temperature is real, but the two little balls story is a stepladder for your intuition, not a photograph of the mechanism.
So I keep the black hole glows and evaporates, which is the astonishing part, and I hand back, there are two real particles and one falls in. That was scaffolding.
Scaffolding, well put. This was Hawking in a famously short paper in the journal Nature in 1974, titled with a lovely question mark, Black Hole Explosions? Barely 2 pages, with the full treatment the next year. And his formula for the temperature has one feature I want you to really feel, because it drives everything after. The temperature of a black hole is inversely proportional to its mass.
Inversely, so bigger means colder? The more massive the black hole, the less it glows?
The more massive, the colder. A big black hole is deathly cold. A small one is blisteringly hot, which sets up a runaway. A black hole radiates, so it loses mass. Less mass means smaller, which, temperature going inversely with mass, means hotter. Hotter means it radiates faster still. An accelerating spiral that ends, in principle, in a final brilliant flash. The most patient object imaginable ends its life as an explosion.
That is wild. So the sky should be popping with little final flashes. Are we seeing black holes go off?
No, and here is a piece of honesty people almost never include. For any real black hole out there today, this is all theoretical. A black hole the mass of our sun would have a Hawking temperature of about 60 billionths of a Kelvin, a whisker above absolute zero, and would take something like 10 to the 67th years to fully evaporate. That is incomprehensibly longer than the current age of the universe.
10 to the 67th years. The universe is about 14 billion years old, so the evaporation has essentially not begun.
It has not begun, and it is worse than slow, in a wonderful way. Empty space today is not empty of warmth. The whole universe is bathed in the leftover heat of the Big Bang at about 2.7 Kelvin, far warmer than 60 billionths of a Kelvin. So a real black hole today is colder than the space around it and absorbs more heat from that background than it radiates away. Every real black hole in the universe right now is not shrinking, it is growing. Evaporation only wins in a fantastically distant future, once the background has cooled below the black hole's own faint glow.
So let me get the honesty exactly right, because this gets mangled. Hawking radiation is a rock-solid theoretical prediction, but it has never actually been seen coming off a real black hole.
Never. Not once. And because real black holes are colder than the sky around them, essentially never will be, by direct detection, the signal is drowned a trillionfold. People build clever laboratory stand-ins, analog horizons made of flowing water, or cold atoms, or pulses of light in a fiber, meant to mimic the same mathematics and show a Hawking-like glow. Some report suggestive signals, but they are analogues, not black holes, and whether they truly reproduce the effect is genuinely contested. So the color of this claim is robust prediction, never observed. A very different color from the falling apple.
Prediction, gold standard theory, 0 direct sightings. But you have been building towards something, because the black hole glows a little is strange. Not paradox-level strange. Where is the crisis?
Hiding in one word, I slid right past. Thermal. A glow that remembers nothing. When I say the radiation is thermal, I mean it strictly. A pure heat glow, like an ember, whose character depends on exactly one thing, the temperature, which, for a black hole, depends only on its mass, plus its charge and spin if it has any, and that is all a classical black hole has. There is an old slogan, a black hole has no hair, no bumps, no texture, no memory of what it was made from. Two black holes of the same mass, charge and spin are perfectly identical, whether one formed from collapsed stars and the other from a galaxy's worth of encyclopedias.
Wait, that is the problem, isn't it? I throw the book in. It had gold letters, specific pages, mountains of detail. The black hole eats it, gets slightly heavier, and radiates that extra mass back out as a thermal glow that depends on nothing but the total mass. The glow does not know it was a book. It would look identical if I had thrown in a rock of the same weight.
You walked straight into it, and I will not soften the landing. The book falls in. The black hole radiates, over an eternity, a featureless thermal glow carrying no imprint of it. At the very end of evaporation, the black hole is gone entirely. No black hole, no book, no clue. Just a fading bath of heat that could have come from anything. The information, everything that made it that book, and not some other of the same weight, is nowhere. Erased from the universe.
And that should be fine? Things get destroyed. I burn the book in a fireplace. It turns to heat and ash. The words are gone. Why is the black hole worse than a fireplace?
The exact right question. And here I invoke the deepest law we have. When you burn a book, the information is not actually destroyed. It is scrambled, smeared into the precise pattern of the smoke, the exact energies of every photon of firelight, the correlations between every ash particle. So hopelessly scrambled, no human could ever reassemble it. But in principle, if you knew the state of every particle perfectly, quantum mechanics says you could run the movie backward and recover the book. Quantum mechanics is reversible, a bedrock principle called unitarity. Information can be scrambled beyond any practical recovery, but never truly erased. The universe keeps its receipts.
So the fireplace is safe because the information is still there, just shredded. And the claim about the black hole is that it is genuinely fundamentally gone, not shredded, gone. And those two things cannot both be true.
They cannot. And there you have the black hole information paradox, a head-on collision between two of the most successful ideas in all of physics. On one side, Hawking's calculation, built from general relativity and quantum fields, saying the glow is featureless and the information is destroyed. On the other, the reversibility of quantum mechanics, saying information can never be destroyed, full stop. Hawking laid it out in a 1976 paper with the blunt title, Breakdown of Predictability in Gravitational Collapse. His position, general relativity wins, quantum mechanics must bend, information really is lost.
And I imagine other physicists did not take quantum mechanics is just wrong about its most basic rule, lying down.
They did not, and the fight got personal in the best way. In 1997, Hawking and Kip Thorne made a formal bet against John Preskill, a quantum theorist at Caltech. Hawking and Thorne bet that information is destroyed. Preskill bet it survives. They signed it, and the stakes were an encyclopedia. The winner to receive an encyclopedia, from which, as they put it, information can always be recovered at will.
An encyclopedia, that is the book from the very top of the show.
It is, and I did not plan the universe to be that tidy. Here is how it resolved. On the 21st of July, 2004, at a big relativity conference in Dublin, Hawking stood up and conceded. He had come around. Information, he now believed, does come back out after all, encoded somehow in the radiation. And he handed John Preskill a baseball encyclopedia.
So it is solved. Hawking himself said he was wrong. Information survives. Roll credits.
And this is exactly where a lazy show stops and an honest one keeps going. Because three separate honesty notes are packed into that happy ending. First, Hawking conceding was one brilliant man changing his personal mind toward what had become the majority view. It was not a proof. Second, even as he conceded, the actual mechanism, how the information gets out, what happens to the inside of the black hole, was completely unsettled, and he admitted it. Third, my favorite, Kip Thorne, his co-bettor, never conceded. So the correct summary of 2004 is not paradox solved. It is expert opinion turned toward information surviving, with the explanation still missing and at least one serious holdout. The community leaned. It did not close the book.
Believed then. Not proved. Believed. Most people now bet the information comes out, but nobody could show you the trick. So did anyone find the trick?
That is the frontier, and it starts by pulling on the thread I told you to file away. Bekenstein's word. Area. Written on the surface, not the volume. Think about ordinary entropy, a gas in a room. Double the size of the room, same gas, and you get twice the entropy. Ordinary entropy scales with volume, with how much you can pack inside. That is the obvious expectation. Now recall the black hole. Its entropy, and Hawking pinned down the exact formula, is 1/4 of the horizon's area, measured in the tiniest natural units of area physics has, called Planck areas. 1/4 of the area.
Area, two-dimensional area, not the volume. So a black hole's capacity for information is set by the size of its skin, not by how much room is inside. That is backwards from the room full of gas.
Backwards and profound. A black hole the mass of the Sun carries an entropy of order 10 to the 77th in natural units, colossally more than the star it formed from, and all of it written on the surface, which leads somewhere head-spinning. The maximum information you can cram into any region of space is set not by its volume, but by the area of the boundary around it, as if everything inside could be fully written on the surface enclosing it, like a hologram.
A hologram, a flat film that stores a full three-dimensional image. So the claim is that the three-dimensional guts of some chunk of space could be completely encoded on its two-dimensional boundary, nothing lost.
That is the holographic principle, and for a long time it was a suggestive slogan without a working example. Then, in 1997, Juan Maldacena wrote down a concrete, calculable case, probably the most influential single paper in theoretical physics of the last 30 years, usually called the ADS-CFT correspondence. Strip the jargon, a particular kind of universe with gravity in it is exactly equivalent to an ordinary quantum system. No gravity at all, living on that universe's lower dimensional boundary. Two descriptions, one reality.
And why does that help with the missing book?
Because the boundary description is an ordinary quantum system, and those are provably reversible. They never lose information. So if a black hole forms and evaporates in the gravity picture, and that is exactly mirrored by a boundary system that cannot lose information, then the black hole cannot lose it either. Not allowed. That was the strongest argument anyone had ever given that Preskill was right.
That sounds close to a proof, so why the careful voice again?
Two flags. First, ADS-CFT is, strictly, still a conjecture. An astonishingly well-tested one, a workhorse thousands of papers rely on, but not a proven theorem. Second, and more important, that special curved universe is not our universe. Ours is expanding and accelerating. His is a different, more convenient shape that made the math tractable. And even granting all of it, the correspondence tells you information survives without telling you how. It never shows the step where a specific bit of the book climbs out in the glow. It says the receipt exists. It does not read it to you.
So we went from "we believe information survives" to "we have a toy universe where it provably must, but we still can't watch it happen, and it's not quite our world." Did anyone actually make the information come out?
That is the next chapter, and it is recent enough that it happened while people your age were in high school. It hangs on a very specific, testable prediction by a physicist named Don Page. The curve that has to turn. In 1993, Don Page asked, suppose information really does survive. Then, as a black hole evaporates, what should happen to the entanglement between the radiation that has already escaped and the black hole left behind? He worked the answer out as a curve over the black hole's lifetime, and it has a particular shape. Early on, as radiation trickles out, the entanglement rises. But if information is truly preserved, at about the halfway point, the curve has to turn over, peak, then come back down, until, when the black hole is finally gone, it returns all the way to zero. That shape, up then back down to zero, is called the Page curve.
And let me guess, Hawking's original calculation does not give that shape.
Hawking's thermal calculation gives a curve that just rises and rises to the end and never comes back, the signature of information being lost. So there is the whole fight turned into a picture. Two curves. One turns over and comes home to zero, information saved. One rises forever, information destroyed. And the concrete challenge became, can you start from gravity, Hawking's own kind of calculation, done more carefully, and get the curve to bend back down? Not assume it. Derive the turnover from the gravity side itself.
And somebody did it.
In 2019 and 2020, several groups did, more or less at once. The genuine, recent breakthrough at the heart of this subject. Working from the gravity side, they found Hawking's calculation had been missing a contribution. Include it, and the entropy curve bends over exactly the way Page said it should. The new ingredient has a wonderful name. Physicists call these extra regions islands, and the deeper technique behind it has an even better name, replica wormholes. I am not unpacking the machinery, It is graduate level and not the point. The point is the result. For the first time, the entropy came out bending the right way, derived from gravity itself.
That sounds like the win. Paradox solved, for real this time. So why no victory lap?
Because I promised to keep the colours clean, and this one is a mix. What is real and solid? The entropy curve now bends the right way from a gravity calculation. True and important, not hype. But the limits all matter. Most of these calculations live in simplified, lower-dimensional toy models, not the full four-dimensional universe we inhabit. The derivations, including those replica wormholes, are still argued over. Serious people have raised real technical concerns about what they mean. And most fundamentally, reproducing the entropy curve is not the same as explaining the mechanism. Getting the graph to bend the right way shows the bookkeeping is consistent with information surviving, but not how a specific letter of the book rides out on a specific photon of the glow. So the honest headline is, major theoretical progress on a simplified version of the problem, not the paradox is solved.
I appreciate that because every popular version I have seen says physicists solved Hawking's paradox in 2019 and stops, when the truthful version is they got the crucial graph to bend the right way in toy models and are still arguing about what it means.
That is the truthful version, and it is a better story anyway, because it is still open. Now, I have thrown a lot of theory at you. Let me anchor it to something you can literally look at, because in the middle of all this argument, humanity took a picture. The portraits.
A picture of a black hole. An actual photograph. The orange ring everybody has seen. That was real.
That was real. And, because it is me, we are going to be exact about what it is and is not a picture of. First, the ground under it. Are black holes even real, or is this all elegant mathematics? Settled. They are real. The Nobel Prize in Physics in 2020 went half to Roger Penrose for proving that black hole formation is a robust, unavoidable prediction of general relativity, and half jointly to Reinhard Genzel and Andrea Ghez, who spent decades tracking stars whipping around the center of our own galaxy and showed they must be circling an invisible object about 4 million times the mass of the Sun, packed into a space smaller than our solar system.
So we knew they were there from how stars danced around them. And then the picture.
Then the picture. A planet-spanning network of radio telescopes linked to act like a single dish the size of the Earth. The Event Horizon Telescope pointed at the giant black hole in the heart of a galaxy called M87, some 6.5 billion times the mass of the Sun. On the 10th of April 2019, they released the first image ever of a black hole's surroundings. A bright ring of glowing matter wrapped around a dark central patch. 3 years later, on the 12th of May 2022, they did it again for Sagittarius A star, our own galaxy's central black hole. The same 4 million solar mass object Genzel and Ghez had tracked, about 27,000 light-years away.
So we have portraits of 2 of them now, and I want to say we photographed the event horizon, but you have got that look, so tell me what I am actually looking at.
Here is the careful truth, and it is thrilling enough sold straight. What you see is not the horizon, and certainly not the inside. It is hot gas, plasma swirling and falling in, glowing fiercely, plus light from behind the black hole, bent all the way around it by the extreme gravity, wrapped into a bright ring. And the dark patch is not the horizon either. It is called the shadow, the silhouette the black hole's gravity casts on all that glowing background, and it is actually much larger than the true horizon, roughly 2.5 times its size, because the bending of light magnifies it. So the honest caption is, a photograph of a black hole's silhouette, outlined by the glowing gas around it. Not a photograph of the one-way door, and nothing we could ever photograph shows the inside. and none of these images show any Hawking radiation. That glow is unimaginably too faint. What you see is ordinary hot matter, blazing as it falls.
A silhouette outlined by the fire around it. That is still one of the great pictures ever taken, and it is better for being described honestly. So, black holes are real, we have their outlines, they carry entropy on their skins, they glow in theory, and we now believe, carefully, that they give the book back somehow. Is there a bigger idea underneath all these threads?
There is, and it is the most beautiful and the most speculative idea in the whole subject. I am going to flag it in flashing letters as a hope, not a fact, before I even say it. Some physicists now suspect that space-time itself, the very stage everything happens on, is not fundamental at all, that it is woven out of entanglement. Is space-time made of entanglement?
Woven out of entanglement. Walk me into that very slowly, because it sounds less like physics and more like a poster again.
It does, and the difference between a poster and physics is the calculation underneath. Remember holography, the boundary description and the bulk with gravity description being the same physics. In 2010, Mark van Ramsdonk asked a simple, devastating question. On the boundary, you can dial the entanglement between parts of the quantum system up and down. So what happens to the space-time in the bulk when I turn the entanglement between two regions down towards zero? The answer was extraordinary. As you remove the entanglement, the space-time connecting those regions stretches, thins, and pinches apart, until, when the entanglement is gone, the two regions are no longer connected by any space at all.
So, entanglement is not something that happens inside space-time. Entanglement is the thread that sews space-time together in the first place. Pull the thread, and the fabric comes apart.
That is the hypothesis, in one sentence, and you said it more cleanly than most papers do. It got a wilder formulation in 2013 from Maldacena, the holography man again, and Leonard Susskind. They noticed a strange echo between two things that seemed unrelated. A wormhole, a bridge in space-time connecting two distant places, and a pair of entangled particles. And they conjectured these are the same thing. Two entangled particles simply are connected by a tiny, uncrossable wormhole. The slogan is ER equals EPR, the initials of the wormhole paper and the entanglement paper from decades earlier, both of which happened to be co-authored by Einstein. And the whole program, that geometry, space, gravity emerge from patterns of entanglement, travels under a banner borrowed from John Wheeler, who said everything physical comes from information. It from bit. The modern version calls itself it from qubit.
That is one of the most beautiful ideas I have ever heard, that the space between things is made of the entanglement between them. So tell me straight, before I fall in love with it, what colour is this?
The deepest colour I have, and I want no ambiguity. This is hoped. Not proved, not even believed, the way the surviving information story is believed. It is a research direction, thrilling, active, serious, pursued by some of the best people in the field, with real calculations behind it, not just words. But it is a conjecture stacked on a conjecture. Emergent spacetime rests on holography, which is itself unproven, and the sharpest versions live in those same idealized toy universes, not ours. Nobody has shown that the spacetime you and I are sitting in is woven from entanglement. Many suspect it. That is a very different thing from knowing it. So when someone says, space-time is made of entanglement, the honest reply is, some physicists hope so. They have intriguing reasons, and it is not established.
I will guard it. Hoped, with real reasons behind the hope, but hoped. Can I try to put the whole night back together in your three colours? I think I finally can. The honest horizon. Here is what we have proved. Black holes are real. Penrose showed they must form. Genzel and Ghez tracked the stars orbiting ours, that was the 2020 Nobel, and the Event Horizon Telescope took the silhouettes, M87 in 2019 and our own Sagittarius A star in 2022. Proved. The size of the horizon is the Schwarzschild radius, which you can get from a first-week escape velocity sum. As long as I never say light gets heavy and falls back, it is geometry, a one-way surface. Proved. And a black hole carries entropy written on its area, not its volume. Strange and solid. Proved.
All flatly true. Keep going. What lives in a slightly different place?
Hawking radiation. The black hole glows. Its temperature goes inversely with its mass, and it slowly evaporates. Rock-solid theoretical prediction, but never seen coming off a real black hole. And because real black holes are colder than the leftover heat of the Big Bang, they are actually growing right now, not shrinking, so we may never see it directly. The lab stand-ins are suggestive and contested, predicted with great confidence, not observed.
Exactly the right shelf. And the paradox itself?
Believed, not proved, the featureless glow seems to erase the book, which would break the reversibility of quantum mechanics. That is the paradox. The tide has turned toward information surviving. Hawking conceded in 2004 and handed over an actual encyclopedia. Holography gives a toy universe where information must survive. And in 2019 and 2020, people got the page curve to bend the right way from gravity itself. But the mechanism, the actual how, and what happens to the inside is still open. Those calculations mostly live in toy models and are still argued over. And Kip Thorne never conceded. The community leans hard toward the book comes back without being able to show you the trick.
And the deep end?
Hoped that space-time itself might emerge from entanglement. Entanglement as the thread that sews space together. A wormhole and an entangled pair being the same thing, it from qubit. Beautiful, serious, pursued by wonderful people, and unproven, resting on conjectures, mostly in idealized universes that are not ours. A hope with real reasons, not a fact.
A flawless accounting, and holding those four shelves apart, proved and predicted, but unseen and believed and hoped, without letting them slide into each other, is the entire craft of doing this honestly. So let me leave you where we started, at the door. You dropped an encyclopedia through a horizon. The old story said it was gone forever. Then Hawking showed the door is warm and asked, where did the book go? And here is the genuinely honest answer, the one I would stake my reputation on. We have finally become fairly sure the book is not destroyed, that the information comes back out, somehow, hidden in the glow. But how it comes out, what it does to the inside on the way, and whether the deepest reason is that space and time are themselves stitched together from the book's own entanglement, those are open. Wide open. Not solved and simplified for you. Open.
And that is the part that gets me. This is not a dusty, settled corner they let undergraduates look at. The turnover in that curve happened while I was in school. Somebody could still be the one to explain the mechanism.
Somebody could. And there is no law that says it cannot be a sophomore who started, the way you did tonight. From an escape velocity sum she thought she already understood. That is the whole reason we do this. The frontier is not a fortress 1,000 miles from your coursework. It is one honest step past this week's homework. And on this particular step, right at the horizon, nobody yet knows what is written in the light.
Then that is where we will leave it, at the horizon, not the bow. Until next time, the black hole is not perfectly black, the book is probably not gone, and where exactly it went is still one of the best open questions we have.